Uh, Good afternoon. Final talk. Um, yeah, hope you like the conference. We'll talk about pain-free object document mapping for MongoDB. I'm Philipp. I'm from beautiful Vienna city of fatty foods, classical architecture, and beautiful women. Maybe, or maybe not. Um, Yeah. So what do I do? In Vienna, I organize some meetups. One about databases, the other one about academic papers. And today we'll see how databases kind of interact with our Java application and why it is painful and how to make it less painful. I also work at a small startup in Vienna. Um, and we have lots of different databases and we kind of feel this pain. So let's see, who uses JPA? Okay. Um, we'll talk about that a bit later. Who uses MongoDB? Okay, also a few. Who has heard, not used, heard of Morphia? Okay, nice. Who has used Morphia? Okay, one. Okay, even better. So let's just say it's like JPA for MongoDB, but better. We'll come to the better in a part. So for those of you programming in JPA, who's written something like this before? Okay, so it's you have an M-to-N connection, and you want to be able to navigate that in both directions. Do you think this is okay? No. Does anyone think this is okay? Because if you think so, you're in denial. Or like in the Stockholm syndrome, where you think, yeah, I'm okay, but you're probably actually not. Okay, so what is the general problem? It's relations versus objects. The so-called impedance mismatch, where you just have you have your nice little relations, which you have in one row, which are kind of flat. You have your single attributes, and then you have references to other tables, which doesn't really match that well to your object structure, which is kind of deeply nested. You have lists, arrays, maps, whatever. And these two concepts just don't match too well to each other. So that's kind of the impedance mismatch and all the pain you are experiencing. And Ted Neward once called it's the Vietnam of computer science, because it's like a never-ending battle and there is just no winning it. And it's a pretty old blog post. It's now nearly 10 years old. Hibernate was just about to start back then. And he just described I think 6 or 8 different patterns how you use stuff like Hibernate or JPA, but miserably fail in the end, and how you then have lots of pain. And now MongoDB comes in and hopefully solves this, because MongoDB's document structure fits object orientation much better. So just to get two terms right, what has been a table in a relational database is now called a collection. It's just a collection of JSON documents. There is no schema inside the database, so you just throw JSON at it and then query that JSON out again. And instead of having rows, you have your JSON documents. So that's all nice and pretty simple. Yeah, so we'll have a random JSON document, and that's just the entire thing you have, and you store it as it is inside the database. So since not all of you have used MongoDB in the past, let's just quickly do a demo and put my calendar and other stuff away. Go away. Yeah, I hope that's fine. Okay. So if you want to talk to MongoDB, it is running. I've installed it on the port 8022, and I'm missing a dot there. Oops. I'll make it slightly larger. Okay, so here we are. So let's see. We are currently in the database called test, which is the default one. We have some databases inside there, but we don't really use them or need them. I'll just use a database called Riga, which isn't there yet, but I can simply connect to it, and then use it. Since there is no schema and there are no explicit databases, whatever I do, it will be created implicitly for me just as I go along. And now just to throw some document into it is I say, into my database, I want to insert a collection person. So what has been a table, I'll just call it collection, and it's called person. And I want to insert some data. And for example, this is now JSON, so now we need to type in JSON. So for example, I say I have a name, and I have phones, and phones might be an array. And after that, I'll close my document. And now inside that array, it's just like regular JSON. I can simply throw in as many attributes as I want again. So let's just say it's fax, and I have a fax number, and I have a mobile number, even though I can also quote that, that doesn't matter. Okay, so we haven't had a database yet. We haven't created any structure. When I say show collections, I had a bad syntax. Oh yeah, right. My bad. So let's create a subdocument. And we've inserted it. And now that we're looking at it, we can see we have our person collection with some data in it and in its indexes, but don't care about the indexes at the moment. So if I say I want to know what's in there at the moment, I can simply say find everything that's in there, and I will find my person. So that's pretty easy. Let's just create another one. Let's say we aim for Peter, and he has a landline. Okay, we've inserted it as well. If we query it, we have both inside our database. Now, since I stored JSON inside it, also to query everything is JSON again. So if I now want to say, for example, I'm looking for something, so I have a JSON document to look for it, and I'm looking for a person with the name Peter. What? Ah, sorry, yeah, it's name. And the nice thing is, since you don't have a schema, nobody's telling you that you're screwing up. You're just not finding anything. So now this finds my person, but for example, if I would put persons here, nothing would be found since there's no schema, and there's no way of telling me that I'm actually doing something wrong, since yeah, whatever you're doing, you're supposed to know what you're doing. So this is one of the not so nice attributes. So don't mistype, know what you're doing, but if you're interacting with it from your Java application, you're probably good to go because you cannot really mistype that easily. Okay, so this is generally how MongoDB works. Let's see. I have my JSON document. Now I need to store it inside my database from my Java application. So there is the Java driver, which works and is pretty solid. Just to store the previous document I've shown you, inside the database would look something like this. So you have something called basic DB object, which is kind of the basic thing. You structure everything around to store it inside MongoDB. So you build this stuff up, and only after putting everything together, then you can insert it. So when I showed this to my colleagues, they were like, no, we're not storing data like this, and we're not interacting with anything like this, because this looks like a major pain in the ass. Yeah, so their reaction was kind of like this, like, are you serious? And yeah, then we decided no. So it is pretty solid. Afir, or Kyle Kingsbury, just recently tweeted about the Java driver and said that it's pretty solid, even though he hasn't anything nice to say about MongoDB otherwise. He likes the Java driver, which is kind of a good thing. but still, like, we were never sure about, yeah, it's solid piece of technology in itself, but we don't really want to use it. So that's how we come to Morphia. Morphia is like an object relational mapper, but since there are no relations, it's called an object document mapper. Since there are only documents, you can only map documents. Yeah. So generally, it's pretty lightweight. It's type safe and type preserving. So you just throw in your Java objects and you're sure you're getting your Java objects back. You don't need any proper casting or anything. So it's just working as expected. Okay. So what do you need to get it running? It's a bit like Hibernate and JDBC. You have your basic Java driver, which is the Mongo Java driver provided by Mongo the company, and you have Morphia, which is also provided by the company. And those two together will form your interaction for your database. And initially, the Morphia has been a community product, and somebody from the community just started hacking at it and worked on it. But at some point, MongoDB decided, yeah, that's kind of nice infrastructure, and integrated it into MongoDB, the company. Okay, so I know talk is always cheap. If you want to try anything, just download the code. You can simply run it. You don't even need to have MongoDB installed, the binary, because there is a Java wrapper around it. So it will, if you just run Maven test or Gradle test, it will simply download some Java binary in the background, run MongoDB as a process, and run some unit tests against it. So this is definitely the easiest way to get started. Just git clone it and hack away. What we're targeting is something like this. So we have employees, which are split into workers and managers. We have companies, and these employees work for companies, and then both companies and employees have bank connections and addresses, and yeah, everything is connected through a base entity. But we'll come to that. So this is just like the overall structure of the code. And as I said, just to run it, download the code, run Gradle test. It will either use MongoDB. If you have it installed on the default port, it will check that and then use your MongoDB, or it will download an embedded version and just run against that. Okay, so since JPA is all about annotations, let's get started on the annotations. First off, collections or tables, how do I get stuff in? This should look pretty familiar. So you have an add entity annotation where you say this is a company, and then you have the class name. You have an ID, which is an object ID and not a nicely structured ID. And you need a no-args default constructor just to get it working. Otherwise, it will complain. But this can be public or even private, but it just needs to be there. It will be accessed via reflection. So this is all you need to store your very simple entity inside MongoDB. Stuff you shouldn't do. First off, inside the collection name, which you can select on your own, do not use dashes. Does anybody have any idea why you shouldn't use dashes in a collection name? And let me put it this way. The shell I've just shown you previously is written in JavaScript. Any JavaScript developers? Exactly. So there is this very nice talk by Gary Bernhardt, where he has, like, at the beginning, he has an array. 16 is like 16 commas. Then he joins 16 times what together. Then he adds +1, and plus is overloaded. So it's either the addition of two numbers, or it's a string concatenation. So you have what1 16 times. And the thing is, if you subtract -1, -1 is not overloaded for strings, so it will try an actual subtraction. So what will be the result here? Na, Batman. Na for not a number. So this is what JavaScript does. And the nice thing is, inside the Java driver, you won't notice, because this is just kindly wrapped away, and everything works. But as soon as you go then to the shell and try to access your data, it won't work, because it will try the subtraction and then say, oh, yeah, sorry, we cannot find that collection name, it's broken. You're out of luck. And there is a strange syntax, so you can put it into braces and quote it and stuff, and then you can access these collections, but it's just the pain in the ass. Don't do it. Secondly, in the entity, we define the value of how the collection will be named. Don't simply copy-paste the entity annotation and anything there, because even though you have totally different classes, since you don't have a schema, totally different classes, if they map to the same collection name, they will be stored inside the same collection name. So you could store companies and persons inside the same collection, and MongoDB wouldn't complain. Since there is no schema, there's no way to tell you that those things are totally different. It's just like the way you annotate it and what you tell the database to do, that will happen. And finally, as you've seen, there is this add object ID annotation for the ID. You could use strings, but don't do it without good reasons. Any ideas why it's not a nice integer or long? Because this is like pretty cumbersome. Like this is hex string, which is pretty long, and it's normally not very nice. Like we've seen in the example, the ID is, so the object ID is the underscore ID. That's the ID that's generated by the database. So instead of a nice ID, you get this ugly thing, and it's very. So if some colleague says, okay, just tell me the ID of the thing that's not working so well, you start like 5, 6, D, 8, 5, and like 512 for something would be much nicer. So?
It's because the IDs can be generated in multiple instances and in multiple places.
Exactly. So MongoDB is generally pretty easy to distribute, but if you have it distributed, you would need some single instance to generate these nice incrementing IDs, which you cannot have. And normally, just to take some load off the server, the client will generate these IDs. So there is a certain schema on it, like you mix together the MAC address, a timestamp, a process ID, an incrementing number, and this is guaranteed to be unique within one collection at least. And yeah, so this is very efficient to generate. The downside is it's not very nice for humans and not very nice to read. But you'll need to live with that. But if you have your own strategy and know how to generate unique IDs, you can do that as well. You just need to be sure you need to care for how to generate these unique IDs. Okay. This is, I think, the biggest strength in general of MongoDB, or how to map objects to documents, is polymorphism. Assume we have a very simple base class. It's an employee who has a name, and then we have a manager and a worker. And the managers can approve funds, and the workers have some experience. Managers obviously don't have any meaningful experience. So you have these things, and you can put them inside your database. And with relational databases, you have 3 options, basically. So the first one is you have a union table where you stuff all these subclasses into the same table. The problem is, so as long as you have just 2 subclasses or concrete implementations and very few attributes, it might be fine. But assume you have like 5 subclasses and each one of them has like 10 different attributes. You will have a table that's mostly consisting of null values and not of actual data. So you have more of a Swiss cheese than an actual database. And it just doesn't really fit that well. So you have just too many null values and it's not much use. The second approach would be to have concrete instances. So for our example, our worker and our manager, we would just have 2 independent tables, one for managers and one for workers, which works in the beginning. But later on, somebody decides and says, okay, give me a list of all the employees of our company. Yes, you can do it. You will need to query the managers and you need to query the workers, and then you will need a union clause on both of them just to get all the names of all your employees. So it works, but again, it doesn't really match to how your program works, and it's all the workarounds. And the third option would be, just as you have your classes, you structure your tables. So you have a base class for employees, and then you have 2 tables, workers and managers, and these are joined to your base table. So every time you need to access a manager or a worker, you need a join to join the base table and the concrete instances together, which kind of works. But again, it's like, you see this impedance mismatch, you just have the data not as nicely structured as in your program, where it's just like, okay, it's a worker object, everything is there, I don't have any problems. It doesn't work that well with relational databases. Yeah, so it's kind of painful. Bob, yeah, might squeeze you, and it might get a little better in the short run, but it's not for the long run. So what can we do? Let's just take the example with Morphia. So we take our entity, we call it employee, so it will be stored in the collection employee. And here we add the option, no class name stored is false. So actually we store the class name inside our collections. You'll see why on the next slide. And then we have our ID, and everything else is just the same as in the plain Java program. And what we'll then have inside our database is we'll have our manager who can approve funds and our employee who has experience. And you have their IDs, and then you have this class name. And based on this class name, you can still discern who is a manager and who is a worker. Which is nice. It's just a little space wasted in the database, but that's probably fine. The nice thing is you don't have any joins, you don't have any null values, you don't have any union clauses. It's just like the right stuff, just as it's stored inside your objects in memory, is just on disk inside MongoDB. It's just the same model. So this is a very nice fit. The only thing people might not like is, what if I want to refactor my classes? So if I want to rename them. Yes, you don't have like an explicit schema in your database, but in this one instance, if you want to rename it, you will need to rename everything in your database as well. So yeah, you cannot get rid of it. On the other hand, if you like already know I will probably rename that stuff, then simply don't store the class names and like put a custom enumeration inside the class just to keep them apart. So you don't need to use that. It's just like a convenience feature which might be helpful, but if you know you'll be lots of refactoring your entities, it might not be the best idea. But I don't know, like maybe it's just because we use this kind of approach, but we very rarely see the need to refactor our class names. We might add new ones or kind of migrate data around, but the existing ones are pretty much the same, at least in the database. Okay, so we have our entities. Now we need to store our properties and access them later on. So the first thing is first name. If you don't have any annotation, it's just stored as it is. It's just a string in the database, and the attribute name is called first name. Surname. This is again for renaming things. So previously you had it named last name, and you had stored it under last name inside your collection. And later on you decide, but surname is the better name, and you rename it. What this annotation basically does is it goes to the database and looks like, do you have an attribute surname? Then take that value and load it into the variable surname. If not, go to the database, check, is there an attribute called last name? If yes, take that value and put it into surname. But whenever you store, you will only store on the surname. So this is kind of a rolling upgrade, and you don't need to do any manual migrations. It's just like the old data is loaded, and every time you save something is saved in the new fashion. So this is kind of nice. Then you have a Boolean to approve funds. You can explicitly say, I have another attribute, manager can approve hires, which is a nice name for the Java programming language. The only thing is, like, you have a very long name you will need to store inside each and every document you store inside the database. So this is a pretty great, or not so great waste of space. So you will have lots of disk space used by that, and also memory. So avoid it. Just to make it a little shorter, we will just store it as hire inside the database. But inside your program, you can still use the full name, and you don't need to make any compromises. And the final thing is, chainable setters are always nice. So, do's and don'ts. Do trim your property names if you're using like the old storage engine. Now there's a new storage engine which can kind of nicely compress all of that away. But with the old storage engine, every attribute name was stored inside your database in each document. So if you have just a Boolean flag and a very long attribute name, it's still taking up a lot of space and it's pretty wasteful. So with that, use very short property names. Use object data types. Any ideas? So we've had, in the code example, we've had a Boolean which was a primitive data type and an object data type. Why could I prefer the object data type? Any ideas? Exactly, null values. The thing is, if it doesn't exist, MongoDB doesn't need to store it. So null values are not stored. The thing is with primitive data types, there is no null value. So the Boolean, the primitive Boolean will default to false, and that will always be stored. So just be mindful of that. If this is what you want, there always should be a value, and you don't want ever to be confronted with nulls, use the primitive data type. But otherwise, if you have something that might be optional, use an object data type and don't have it in your database at all. And yeah, provide chainable setters, or like, I've thrown all of them out. I'm now using Lombok, which is just annotation based. So you simply say, I don't know, add setter, add getter, and add default constructor, whatever. So you just get rid of all the boilerplate code. Who is using Lombok? So few. It's amazing. Or you're probably not using Java, but Scala or something. No? Okay. Look at Lombok, it's pretty great. So, indexes. Indexes work pretty much the same way as in regular databases. So it's just a B+ tree, and it makes your searches much faster. So it makes writes a little bit slower, but searches much faster. Otherwise, you need to look inside every single document of a collection to find something, and that will be pretty slow. With indexes, you will just have your nice tree structure, and it's just very few compares to find the value you're looking for. So here we have two indexes defined. The first one for name, consisting of surname and first name. And this will help you both for queries with only on the surname or on the combination of first surname and then first name. This index won't help you for queries just on first name. Yeah. And at the bottom, email needs to be unique and sparse. Sparse basically means if something is sparse, there can be no more than one null value, because like if something is unique, like kind of the null value is also unique, so just a single element of those can be null. Otherwise, you need to say sparse true, then you can have either multiple null values or a unique actually existing value. But if you just don't care about that, just let's sparse it false and just have one single null value available in the unique collection. One thing that's pretty nice about MongoDB is that, or depending on your point of view, like in relational databases, you have pessimistic locking. So the pessimistic approach is always like, I assume something will go wrong, so whatever data I'm currently changing, I will lock. So whenever somebody else is trying to access it, they will run into that lock and their operation will fail or will be blocked. And MongoDB takes kind of the positive or different approach, where it assumes like the operations will probably go right and no two writes will just conflict with each other. But if they do, I will only then raise an exception. And then you need to handle the exception yourself. But this is like kind of the underlying nature. Like relational databases are very strict and very much focusing on like doing everything correct, but that can slow them down considerably. And MongoDB is taking the opposite approach, where it will go right, I assume, but here are the tools just to recover just in case it doesn't. So what you need to do is you just need to add a long variable and annotate it with add version. And at every write you do at the database, this version will be incremented. So after the first write, it has the number long 1. As soon as you update that document, it will have version 2, version 3, whatever. And when you read a document, you will see, okay, it has version 3. If I write it back, the write operation, so this is like atomic, if you write it back, it checks, I will only overwrite anything in this document if it has still the same version I have read. If that version is different, my write will fail, because probably somebody in the meantime, between me reading the value and trying to write it back, somebody else has also read that value and has before me written that value back, and I would probably overwrite their operation. And yeah, not good. So you have optimistic locking, where you simply have the version numbers, and only if you have the current version number, you can update a document. Yeah, so something that MongoDB and like all of the non-relational databases don't have are joins. So what you can do is you can either embed something, which is the subdocument, which we've seen in the previous example, where you just add a subdocument with curly braces inside one other document, so you can stuff things into it. For example, a person has a bank account, and the bank account is absolutely tied to that person, so you can simply store it inside that person. On the other hand, something might be, yeah, like in some way connected, like an employee and a company. But like there are two independent things, and you cannot really embed the company inside the employee, and you cannot embed all the employees inside a company because it just would be too big and doesn't really make sense. Then you can annotate it with add reference. However, this is not a database feature, this is a feature of the Java driver, and it's a convention of like all the drivers of MongoDB. There's a specific syntax it uses in the database, so all drivers will recognize when you do something like that. But what it tells the database is like, okay, you have one document here and you have a reference to this other document there. So what I do, as soon as I find this one document, I will eagerly load the other document now from the database as well. You can annotate it with lazy, so you can lazily load stuff, but by default, it will be eagerly fetched for you, which is very convenient in the beginning because you don't need to do anything. It will just, you load one object and everything that's referenced inside that object is magically loaded into memory as well for you. The only thing is, if you don't really think about it, you will have like big chains and you just think, okay, I'm just loading this one thing. And for the database, it actually means it needs to fetch like 10 different documents. And it will get even worse if you have like a list of companies and you will put an add reference there. For example, you have like a list of 20 companies, then 20 independent documents would need to be fetched. And this is not batched or anything, this is just like independent queries. So like, get this ID, get this ID, get this ID. So this can become painful. Okay, so now we know how to annotate everything. Let's look at some queries. Save or upsert. Upsert is the big thing in the latest Postgres version. So it's basically, it says, okay, I have a JSON document here, insert it inside the database. And if it has an ID and something with the same ID already exists in the database, simply replace it. I don't care if it's an insert or an update actually, it's just the same operation. It's just like a save. If it doesn't have an ID yet, a new document will be created. If it has an ID, any existing document with that ID will be replaced. Okay, so for example, if we want to store different entities, we can just call our data store and say save on top of that, which is like a lot of duplicated code. We'll come back to that in a few minutes, how to improve on that. Getting data is pretty simple. You have your data store, you say find like whatever class you want, and then you can have a nice fluent interface where you can simply say, okay, the field email address should be equal to the email address, or like I want the list of all the employees, which will work for small data sets. If you have thousands of documents, this is not a good idea, but paging is supported. Or like get all managers. So this is like the specification of our generic or the abstract class we've seen previously. Here I say find all my manager entity classes where the class name equals my manager entity class. And this will normally throw a warning at you because it says this attribute class name which you're referencing here, this is not in your class. What is it? It's probably something wrong. But actually this class name has been added by Morphia in the background when we set the no class name stored false. We actually stored it, so this is kind of an internal thing, and for that you need to disable validation. Otherwise you will always get a warning, because Morphia kind of tries to see, okay, all the attribute names you're using, do they exist inside your class? If not, you're probably doing it wrong. Okay, something to watch out. It's equal and not equals, but your compiler will warn you, so trust your compiler. Performance-wise, for example, with the email address, email addresses don't really matter if they're in uppercase or in lowercase. So one performance tip would be just normalize the data before you initially store it inside the database. So just call a to lowercase on the email address before storing it, so you can later on work on exact matches. Otherwise, search in MongoDB is case sensitive. You will need to fall back to something like regular expressions, which are extremely slow, so don't do that. So kind of normalize your data wherever it is possible and makes sense. And there is much more, like regular expressions, stuff exists, stuff doesn't exist. You have comparisons, you have like skip, sort, limit, all the stuff you would expect in a relational database. So the expressiveness of MongoDB and also Morphia is pretty good. This is like the database that is like kind of the most expressive in general query terms. And also there are many other features accessible also from Morphia, like kept collections, where you can simply say, okay, this thing should just use 5 megabytes of storage. If it's more, just overwrite the oldest data, like for example, log data. You just want to keep the oldest 5 megabytes of some log data, just make it a kept collection, and the oldest data will be automatically overwritten. You have like a pretty weak full text search capabilities, but you have them. Full text search has for years been the #1 upvoted feature on MongoDB, and I think it took like 3 years until they finally decided to do something. And yeah, they say it's like an 80-20 solution, so like 80% of the use cases they cover and 20% they don't. I would say they cover like 20% of the use cases and 80 they don't, but if you need very simple full text search, MongoDB can cover you as well. You have an aggregation framework, which is very powerful, where you can do aggregates like in relational databases, so you can do a group by some average. This is something you don't have in, I think, pretty much any other NoSQL database. And geolocations are also supported, like Foursquare, where you could check into places and then became the mayor. They had been using MongoDB for a long time for their check-ins. Okay, some patterns. We've been using Morphia for like 3 or 4 years, and we've found some practices which can be pretty helpful. The first thing is have a base class. So we have an abstract base class, and everything we implement inherits from that abstract base class. The thing is, you define all the attributes everything has, like the ID, we have like a creation date and the last change date, and the optimistic locking, that's all defined there. And we have, you need the default constructor, and we have getters for these attributes. You don't need setters. And then we have, it's like a hook. You can define a pre-persist. So right before inserting that data into the database, this method will be called, and you can do some action with it. So you have both a pre-persist and a post-load. So either right before saving the data or right after loading the data, you can do some changes inside that data. And we use it, for example, to save like, okay, this has been initially created at this date and last update at this date. Might be the same if you run an update, you will get the latest timestamp. And based on that, you can use generic queries. Like I've had previously this persist example where for each class I needed a dedicated persist method. Now if you have the abstract base class, you can use generics, just use one generic persist, or you can have one generic count, how many documents do I have in that collection, or you can just like query one document by ID out of whatever collection I have based on my abstract base class. So this can be pretty convenient. One thing MongoDB doesn't have is, so not all data types are supported. The big one is bigdecimal. Bigdecimal is not supported, and as soon as you have anything to do with money, please use bigdecimal, don't use float or double. You will have rounding errors and everything will be terrible. So use bigdecimal. The problem is Morphia doesn't support bigdecimals. So you have 3 approaches. So the first one will work, but it's not nice. You can just annotate it with @serialized, and it will just serialize the Java representation inside your database, which is not really human readable and not really searchable. So it works, you can store your data, you get the the same amount out of the database, but you cannot do any manual queries. So this is not so nice. The other thing is you can like build in a hack. You have your bigdecimal with a salary, and then you do a manual toString in the prepersist and a from string in the post load. So you can just manually transform it to a string and load it back. But you need to do that for every single bigdecimal you have. So the add transient tells the database, don't save or don't even try to save the attribute salary inside the database, but we have a salary string there, and then we have like two methods. In the prepersist, we say, okay, use a toString on it, and in the post load, like create the bigdecimal from the string again. It works. It's just extremely ugly. And if you have many bigdecimals in your database, this is a pain. The third option is much nicer. You can register custom converters. So these are not just for bigdecimal, but like you could convert your own attributes, whatever you want to do. So I've seen some crazy stuff where people like try to change the structure of their documents and everything. I'm not sure if it's a good idea, but it's generally possible. So you simply register a converter, and then you can just use your bigdecimals and you don't need to care for anything else. Yeah, the code is pretty small, but it's widely available on the internet. Everybody is just copying that into their project. This is just how to convert bigdecimals. So you have an encode and a decode method. You need to implement those two, and you're good to go. So this is pretty nice and extensible. Okay, other stuff that might be of interest. So if you're more on the Spring data train, like probably Jürgen would have told you yesterday, just to use Spring Data MongoDB, which is definitely a nice project. So if you're kind of on the Spring side of stuff, it's a good option. It's widely used. Features are pretty much the same, I guess. It's just a matter of taste. The second thing is fake Mongo, also called Fongo. I think it has been implemented by Foursquare, the location thing, because they have been using MongoDB so heavily, and they have like an not fully complete, but a pretty big Java implementation. So you don't need any binaries running for your unit tests. It's just like a Java mocking thing for your unit tests. And the final thing is Critter. It's written by one of the Morphia maintainers. And what he didn't like is at the top of example, you have like if I write a query, I have always these strings I need to pass in. MongoDB or Morphia checks, do I have an attribute actually called bookmark or database? And it will throw a warning if I don't have that. But still, it's easy or relatively easy to break that because it's just strings. And what Critter does is it, when you compile your code, it will kind of extract all the available attributes. So you will have type-safe attributes. So you can use then bookmark criteria.bookmark and whatever value you want to check against, but you don't need to pass around any strings manually. So this is handled by the database. It hasn't seen much attention yet, but at least it's available, and it's, yeah, I think it's a good step into the right direction. Yeah. The question that always comes up is, but is it fast? And the thing is, I always like to show this comic because this is like the best explanation for is it fast? Because the similar conditions are really what make the difference. Like whatever benchmarks I do, the only thing I can tell you for certain is my numbers will be different than your numbers, whatever you do, because like you use a different version, or you use a different operating system, or your read to write ratio is different, or your hardware is different, or whatever is different. And the funny thing is like MongoDB, Cassandra, and Couchbase have been like in a long battle about users, and I think pretty much a year ago, each of them did a benchmark with the other two, and each of them managed to be at least twice as fast as the others. So each one found like one edge case, which was just tuned for their specific mode of operation, or they used an old driver or whatever, just to be much faster than their competition. So whatever numbers you see, I wouldn't believe them too much. Yeah. Is it fast? Unfortunately, you will need to write your own prototypes. There isn't just no way around it. Yeah, so conclusion. Stuff you won't get with MongoDB or Morphia is like there are no transactions. So like a single document is written atomically, so either it's written entirely or not, but multiple documents are totally independent. So there is no transaction spanning more than a single document. It's just not available. Structure your documents accordingly. So if you embed something inside another document, that's written atomically again. If you have a use case which absolutely needs multi-document transactions, MongoDB is not the right thing to use. It's pretty simple. But you can get pretty far depending on how you structure your data. And you don't have joins. You have something now bit similar in the aggregation framework, but you have no like powerful joins you're used to. So again, it's mainly in how you structure your documents that can be pretty challenging in the beginning, but it can get you pretty far. Things you will get instead, like pretty rapid development, replication and sharding, which are more like operations topics, which we didn't cover yet. And you don't have an impedance mismatch. Instead, you will have like an impedance match, where you have rich documents which fit your object structure pretty well. Yeah, so to sum up, like my colleagues, or we as developers, we love Morphia. And I've heard that even the minions love it. And just for the final question, like, this guy is doing a MongoDB talk and wearing an Elastic shirt, which is strange, but I'm about to join Elastic. So if you have any Elastic questions, or if you have any MongoDB questions, just come to me afterwards. And yeah, that's it. Any questions? Wait for the microphone. Thank you.
Hi. Thank you for your talk. I have a couple of questions. The first one will be about the data migrations. So obviously, in the process of software development, there will be time when you have to refactor everything in your code, rename classes or move them in different packages, or just restructure your domain. So you showed us one example of how can you manage that with the annotation also
Load?
yeah, also load, but in case you need something more complicating than this, do you have any tools for data migrations, such as like Liquibase for SQL or something like that?
Yeah, I think for Liquibase there is an open ticket, which has been open for years, and I don't think it will ever happen because the concepts just don't match. So our approach has always been like, it's part of the application. I think this is kind of like, the whole NoSQL movement is like, take work and logic out of the database because that's not where it belongs and it's hard to scale, and keep a bit more in the application. And this is just the same with migrations. So we will normally just have like some code reading the old data and like changing or mixing it up and then saving the new stuff. And then we normally just leave that in for like 1 or 2 months. And like everything that has been touched in the meantime or saved will be in the new format, and then we'll just run a manual query like, okay, what hasn't been migrated yet? And we'll then just manually push those migrations through, and then we'll clean up the code again. So it's a bit like feature flags where you have different things in your code.
Okay.
But there is, yeah, since there is no schema, you cannot have any alter statements or something like that. Yeah. But like alter statements are painful as well. So if you have a very big table with gigabytes of data, that will probably lock your table, which might not be acceptable
Mongo
as well.
Doesn't have schema, so it doesn't have DDLs.
Right. So it doesn't have kind of the schema change pain, but it's kind of, this pain is then put onto the developer to provide the right code for the migration.
Okay, so your approach is similar to ours. Okay, yeah.
Don't think there is another option.
Okay, the other question I had is obviously you're not only querying your data with those simple queries, you also use segregation pipeline, which is pretty cool in my opinion in Mongo. So how do you manage to do that with Morphia? Because as far as I know in Morphia there is no way to do those segregation pipelines.
Hasn't it been added? I mean, I think that the documentation is pretty bad, but you always need to go to the source code. So like my approach is like, there is So feature-wise, I think it's pretty much there. So you have like the geo stuff is there, the aggregations is there, even the full text search is in Morphia. It's just not documented. You will need to go to the unit tests. No, like the unit tests are kind of the source of truth, and there you can see how it's actually used. We can look it up afterwards, but I was pretty sure that I've seen something about the aggregation framework. I think it's there.
Okay, because about a couple months ago in our company we struggled with that and we didn't find anything, so we migrated to Django.
Okay.
That instead.
Okay. No, like the documentation is pretty bad, but the unit tests are normally. So the
Okay.
unit tests are our source of truth.
Maybe I'll have to view the source code. Okay, and also one thing I wanted to mention about tools you recommended. There was the second one, Fongo,
Yeah.
for embedding Mongo. We had a lot of problems with that because it's a tool implemented in Java and it doesn't implement many of the features Mongo has. So for everybody who wants to develop with Mongo in Java, I would like to recommend another tool. It's called Flapdoodle Embedded Mongo. It runs a separate process. It actually downloads a binary of real MongoDB and runs it in a separate process, so Java can connect to it. And
If you download the application, the demo application, it uses Flapdoodle as well.
yeah, well, we found it better because we used the aggregation pipeline, which wasn't supported in Fongo.
I guess this is kind of the discussion of the purity of tests. Like, should you use external binaries or should like unit tests just touch Java code? But we also decided like forget the purity of the tests.
Okay.
Like we want to test the real thing, so we always download the binaries and test it like that. Yeah, that's
Okay.
true.
Well, we actually had a problem where our tests were green, but in production it didn't work. So that's why.
Yeah,
I
you've
wanted
kind
to
of
recommend
mocked
this.
your own world then.
Okay, thank you very much.
Any other questions? Do we have time for questions? One? Okay, one final question.
Yeah, so references and kind of controlling lazy or eager logging. So I rather than using the annotation while defining the entity, I would like to do that at query time. Is there a prefetch or something?
No,
No?
you
Okay.
can just build it like yourself. So we've done that as well, where we simply kind of have like our own ID, and we don't use add reference, but we kind of put in a unique ID, like in a field, and then run manual queries.
Okay.
So you can either have it eagerly fetched, lazily fetched, or do your own. But unfortunately, there's no kind of fine tuning, or it's not the query time feature. Yeah, as far as I know. Okay, so thanks.